There are some interesting kind of problems you can solve if you know that two events are independent. I'll take some examples. Okay, before taking the example and explaining you, let me explain you some properties here. From that we can take the example. Okay, now let us assume that two events A and B are independent, right? Which means we know that P of A intersection B equal to P of A and B. P of A into P of B. So if A and B are independent, then we can say that, what I mean to say is like this: if A comma B are independent events, then if A and B are independent events, if we can find it out, then A comma B complement, B complement comma A, and A complement comma B complement. So what I mean to say is, if you somehow found out that A and B are independent events, then we know that P of A intersection B is A P of A into P of B. Okay, leave that part. If A and B are independent events, then A and B complement are independent, B complement and A are independent, as well as A complement and B complement all are independent. That is what I mean to say. So it is very easy to prove. You can remember them directly, or okay, let me prove it. If you want to prove it, I'll just prove it also. Let's see this. If you have to prove that A and B complement are independent, then what should I prove? I should prove this: P of A intersection B complement is equal to P of A into P of B complement, isn't it? That is what we talk about independent events. Two events are said to be independent if this formula holds. A and B complement are going to be independent if P of A into P of B, P of A intersection B complement is equal to P of A into P of B complement, isn't it? Now let's try to prove this one. Now let us say we have A here and we have B here. Now what about A intersection B complement? A intersection B complement is nothing but this part, isn't it? See, I'm just proving it from the set theory rules. So A intersection B complement is going to be this part, isn't it? So how can you write A intersection B complement? I'm just taking LHS. Left hand side is P of A intersection B complement. Now that equal to P of, if you see this, now this part is nothing but P of A minus P of A intersection B. If you can write like that, this part is whatever is present in A minus whatever is present in A intersection B. So this is equal to P of A minus P of A intersection B, right? Now since we know that A and B are independent, we already know that P of A intersection B equal to P of A into P of B. So I'm going to write like this: P of A minus P of A into P of B. Now what do you get? If you take P of A as common, you are going to get 1 minus P of B. Now I already told you that 1 minus P of B is nothing but P of B complement, that equal to P of A into P of B complement. Got it? Okay. And now next we have to prove that this B prime and B complement and A are independent. If I have to prove that, I should prove this: P of B complement intersection A, it is equal to P of B complement into P of A. This is what I should prove, right? Now what can we say about this? Oh, it is same, is it? So I have to write it in a different: A complement and B. So I have to take it as A complement and B. I have to prove this one, right? Now if you take the set theory diagram and if you analyze it, this part is nothing but P of B intersection A complement, right? Which means it should be present in B and it should not be present in A, which means this part. Now how can you write it? It is nothing but P of B minus P of A intersection B, isn't it? Now if I take left hand side, I can write the left hand side of P of A prime intersection B as P of B minus P of A intersection B. Now we already know that P of A intersection B is equal to P of A into P of B, that equal to P of B minus P of A into P of B. Now if you pull out P of B as common, then we are going to get 1 minus P of A. Now it is nothing but P of B into P of A complement, right? So therefore we got it. So they are actually independent. Now what about the third one? We have to prove that A complement and B complement are independent. How can we prove it? P of A complement intersection B complement should be P of A complement into P of B complement. This is what should happen. Now let's try it. Now I can write this one as, this entire thing as P of A union B LHS, right? P of A union B whole complement. Now we know that it can be written as 1 minus P of A union B, isn't it? And now we know that P of A union B is equal to P of A plus P of B. See again, how did I write this? This is again from the set theory only, right? So we know that A prime intersection B prime is nothing but A union B whole complement, and we know that P of E complement is equal to 1 minus P of E. That is where I'm taking it from, and minus P of A intersection B. So whatever it is, ultimately we should write it in terms of P of A intersection B, because that is what we know. P of A intersection B equal to P of A into P of B, right? Now how can you write this? 1 minus P of A minus P of B plus P of A into P of B. Why? Because we already know that since A and B are independent, P of A intersection B is going to be P of A into P of B. Now what is this one? So 1 minus P of A minus, if you take P of B, it is going to be 1 minus P of A. Now if you pull out 1 minus P of A as common, then you are going to get it as 1 minus P of A into 1 minus P of B, which is nothing but P of A complement into P of B complement. So that is how we can say that A complement and B complement are independent. Got it? So if A and B are independent, then we can prove that all these are independent. It is not just for two events, you can prove it for more than two events also. If you can find out that E1, E2, so on, En are independent, then you can just use that formula. Like you can say that I'm talking about this. If you see that E1, E2, so on, En, there are n events, all these n events are independent, then you can take complement of any one of them and you can say that all these events will be independent, or you can take complement of all and you can say that all are independent, which means you can play with the complements as well. So why should this result be used, or where is it useful is, I'll just take an example in order to show how we can use it. Okay, in the next video I'll take an example.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year, and in India the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.